Hey guys, it's Miss Johnson here, and I'm here to bring us our video for our notes on solving systems of equations. Today we're going to talk about how to solve systems of equations using a couple of different methods. So our example up at the top of the page talks about the initial cost for Travis and his band to record their first CD was $1,500. Each CD will cost $4 to produce. If they sell their CDs for $10 each, how many must they sell before they can make a profit? Okay, so it's a common question. You're looking at how to make a profit. We have two equations that we need to write. One of the equations is the equation for the cost of the CDs. So we want to think about what is Travis and his band spending money on for each CD or for making his CDs. Well, if I say that X is the number of CDs, okay, because it's always good to make your create your variable, and then Y is the dollar amount. Okay, I'm going to say that the cost for the CDs is going to be $4 times each CD plus the $1,500 that he has to spend initially. That's how much money it's going to cost him for each CD. Then it says the equation for income of CDs. So the income that he makes is $10 per CD. Now the question is, how many must he sell before they can make their profit? Now you can see on your notes page that you're given the graph of these two equations put on a coordinate plane. It's right here. So if we look at the graph of these two equations, you've got both lines. Here's the 4x plus 1500 line. That's this one right here. You can see the equation. And the bottom one is the 10x line. So that's the equation for income. This one up here was the equation for cost. So you can see that there's a point of intersection here. Okay, we've got a point of intersection, and that point of intersection is at 250, 2500. Now what we want to ask ourselves is, what is that representing? What does that mean? Okay, well this point is telling us that it's kind of like his break-even point. It's the point where profit and cost are the same. Okay, the point where profit and cost are equal. So then we can also call that, or we've referenced that as the break-even point. Okay, so that tells us that at that point he's sold 250 CDs and made 2,500 bucks, and that's his break-even point. Anything beyond that, now he's moving into profit. So now he'll be earning some money instead of having to pay money, which is good. That's what bands, musical artists usually want to do. So when we think about systems of equations, we're thinking about more than one equation with the same variables that are usually graphed on the same coordinate plane. Okay, so it's two or more equations with the same variables that we want to put together. We merge together somehow. And there's three different ways to solve them. We're going to talk about all three of those ways today. The way that we just looked at was graphing. We can also use substitution. That's another method. Oops, substitution. And the other way that we can look at is called elimination. So substitution and elimination. That's another method. Elimination. And we have three different types of solutions that we can see for these as well. One type of solution that we can see for these systems is having one solution. And that's like what we just saw, where there's a point of intersection on the graph. Then another type of solution that we can see is none. Sometimes systems have no solutions. That happens when we're given parallel lines, or in other words, lines with the same slope, because they'll never intersect, so there's no point of intersection, so no solution. And then the last one is when we have infinitely many solutions. And infinitely many solutions occurs when we have what's called coincident lines. Or in other words, lines that really end up having the same equation. If they end up having the same equation, then they're going to be in the same place. They're going to lie one line right on top of the other. So that has infinitely many solutions because every point is on both lines. So those are the three different types. Now let's do some practice with graphing equations. We have a couple choices with graphing equations. You can either use the intercepts, the x and y intercept, to put them on the graph, or you can put it into slope-intercept form. Now I typically like to put things into slope-intercept form just because I think that's how we're used to graphing them. So that's what I'm going to do. I'm going to start with the top one. 2x plus y is equal to 5. Subtract 2x, and I get y is equal to negative 2x plus 5. So there's one line. Then I also need to do the bottom line. I have x minus y equals 1. I need to subtract x, and I end up with negative y equals negative x plus 1. And then I need to divide by the negative 1 to get rid of that negative. And when I do that, I end up with, let's get a little space here, positive y equals positive x minus 1. So there's my other line. Now this is a system, so they need to go on the same coordinate plane. I'm going to start with the blue one. I'm going to go up to my y-intercept of 5, so there's my y-intercept, and then use the slope. Slope is negative 2 over 1, so I need to count down 2 places, then write 1. Down 2 places, write 1. Down 2 places, write 1, and you can do that a few times and put your line in. It helps to use a straight edge, especially when you're trying to find the point of intersection. If you guys use like the edge of your notebook or your binder, or if you have a ruler, it helps to get a nice straight line in there. And then the red one, I have a y-intercept of negative 1, and then my slope is 1. So up 1 over 1, up 1 over 1, up 1 over 1, and there's the line for that one. My lines are not very straight. Hopefully you're a better artist than I am. All right, so now what we're looking for is the point of intersection, if there is one. Well, in this case, it's very obvious to see. Here's where the blue and the red intersect each other. So we need to figure out what that point is. It happens to be over 2 up 1, which is 2, 1. That's our solution. Okay. Let's try one more graphing here. For this system, we have the equations 5x plus 4y equals 7, and we also have y equals negative 5/4 x plus 4. So I want to put both these lines on the coordinate plane. I need to, this bottom one's in slope-intercept already, which is helpful, but I need to put the top one in slope-intercept form. So I'm going to do that first. 5x plus 4y equals 7. I need to subtract 5x. I end up with 4y equals negative 5x plus 7. And then I need to divide by 4. Divide by 4. And I get y is equal to negative 5/4 x plus 7/4. Oof, that's a fun line. Okay, so if we put the purple line on the coordinate plane, 7/4, goodness. 7/4 is almost 2, but not quite to 2, so it's probably going to be just a little bit under. And then I want to go up, or I'm sorry, down 5 units and over 4 units. So I'm going to go down 1, down 2, down 3, down 4, down 5, over 1, 2, 3, 4. So I'm a little bit below this line, right about there. And if I connect those points with a line, maybe I can use my line tool. That'll be a better option for me. Maybe. We'll see. Oh, that looks pretty good. Need another arrow though. So there's the line for the purple one, and then I also have the blue one. Now my y-intercept is positive 4, up 1, 2, 3, 4, and then down 1, 2, 3, 4, 5, over 1, 2, 3, 4, and then again I have a line there. Should have used my line tool again, that worked out nicely. So there we are, there's the 2 lines. Now, I don't draw the best, which you can obviously see, but we can see very clearly from this picture that these 2 lines are going to be parallel. We have parallel lines, and if you think back to chapter 1 and chapter 2 where we talked about this, mostly in chapter 2, notice that the slope here is negative 5/4 and the slope there is negative 5/4. So you can see that they have the same slope, which tells you they are going to be parallel lines. So when we have parallel lines, when we have a set of parallel lines, that means we have no solution. Woohoo! So there are no solutions to this system. There will never be a place where they intersect. All right, so I'm going to stop our video there for today. Thanks for listening and have a good night. Don't forget to go back to Schoology and take your quiz, and I will see you all tomorrow.